All right, so let's go ahead and get started. Good morning, everyone. This session is called JavaScript, the assembly language of the web. And the mic's pretty hot, so I guess everybody can hear me in the back. This is great. I don't have to project at all. Nice. All right, so good morning. Hopefully I can help you wake everybody up. I know the last day of a conference is usually a little bit, difficult to get started. Is everyone having a good time? Yes? Okay, so the thumbs up is a good sign, so that's good. All right. Okay, so just a few words about myself. My name's Kito Mann. I run a consulting company that does training, consulting, mentoring, etc. for JSF, Java EE, Liferay, and related technologies. I wrote a book a long time ago about JSF. I run a website that needs a design overhaul called jsfcentral.com. I also co-host the Enterprise Java Newscast, which I encourage you to check out. If you're into podcasts at all. It's basically every couple months or so, me and a couple other guys sit around and talk about latest releases in the Enterprise Java world. Everything from, new versions of Tomcat to new versions of common libraries that we all use to new versions of app servers, Scala, all sorts of fun stuff. So I encourage you to check that out. I speak at lots of conferences like this one, and I'm also a member of the Java community process. But what I'm talking about today is JavaScript. So how many of you guys have to write JavaScript on just about every day or so? Okay, so decent number of you. How many of you like JavaScript as a language? Okay, so most of you. Well, I'd say maybe a little bit more than half of the people that raised their hands said so. Okay. So when you take a step back and look at sort of the explosion of the world of JavaScript over the last few years, you could say that JavaScript is the assembly language of the web. Okay. How many people here have actually seen assembly language? I'm just curious. Okay, so a decent number of you. At the university, I'm guessing? Anyone actually write assembly language in production? Wow, cool. All right. Last time I saw it was university. JavaScript looks pretty different than assembly. Assembly is very low level, right? But if you think about what assembly language really is, it's considered a low-level programming language, but it's for a computer or other programmatic device in which there is a very strong, generally one-to-one correspondence between the language and the architecture's machine code instructions. Each assembly language is specific to a particular computer architecture, in contrast to most high-level programming languages, which are generally portable across multiple architectures, but require interpreting or compiling. So that's the Wikipedia definition, and we all know Wikipedia is always right, right? So if you think about this particular definition, you can think of the web browser as essentially a higher level computer architecture, right? Because essentially what we're looking at is the ability to run web applications, and that's what we're talking about in this, for the purposes of this discussion, okay? And if your target platform is the browser, then your target architecture is the browser, right? And for this particular browser that supports newer standards like HTML5, CSS, etc., the machine instructions for interoperating with those technologies is JavaScript. And that is, it's sort of a happy accident or unhappy accident, depending on your perspective in history, right? JavaScript started out as a project at Netscape, right? It's called JavaScript because at the time, Java applets were cute and hip, and Netscape wanted to jump on that bandwagon, so they have a license, or they got a license from Sun to use the name Java and give it a vaguely similar syntax. So they called it JavaScript. In reality, we all know JavaScript is really nothing like Java. And as a matter of fact, it's actually ECMA script. It's a standard. But JavaScript is the common term. And the reason it is the set of machine instructions for browsers is pretty much because of Netscape. Because no one else has been successful in adding a language to browsers since Netscape. And the reason Netscape was able to do it is because they were there at the very beginning, right? Back then, Netscape was setting all the standards. They were coming out with all these cool new features. Everyone thought it was the coolest browser ever. And they added JavaScript. And every browser since then has included JavaScript. But you may have noticed that there are no other languages which the other browsers include, and I don't think there ever really will be. And the reason is that it's very hard to get tech companies and organizations to agree on a standard. So even if, for instance, Mozilla decides, okay, we have a cool new language we want everybody to use, why would Google or Microsoft use it? What actual incentive do they have as a company, right? And right now, Google and Microsoft control most of the browser market. Netscape's really faded away. I mean, Mozilla has faded away a lot, Firefox, all right? So I seriously doubt anytime soon we're ever going to see another programming language built into browsers. But on the good side, the JavaScript interpreters have gotten a whole lot better. They've gotten faster, they've gotten more powerful, and there is still work being done to standardize newer versions of the language, although some of the more ambitious attempts have failed. So they're working on ECMAScript 6, and I think 5 was basically a failure. So this concept of JavaScript as an assembly language isn't something new. I didn't make it up, unfortunately. I could have just claimed credit. But if you type in this phrase into Google, you'll find a post by this guy, Scott Hanselman, who works for Microsoft. And he posted something about this in 2011. And of course, he got a lot of flack for it. You know, they're like, people are like, oh, no, it's not, you know, JavaScript is not assembly. What are you talking about? You know, so he emailed a couple people, Douglas Crawford, the inventor of JSON. He talked to Brandon Ake, who's the inventor of JavaScript, and a couple other people. And, you know, it's a roughly accurate statement. So this is what Brandon Ake said, the inventor of JavaScript. He said, I said JS is the x86 of the web a couple years ago. And this was a few years, so this is, you know, probably 2009, 2010 when he said that. But I can't claim it's original. So someone else had said it that year. The point is, JS is about as low as we can go. But we have higher level facilities. And he goes on and talks about some of the new features being added to the language. So essentially, when we say as low as you can go, we're saying that the browser, you know, that's pretty much the lowest level interface you're going to have to a web browser right now, right? Douglas Crawford, the inventor of JSON and the developer of JSLint, also said a couple things. He said, I think it is a little closer to the mark to say that JavaScript is the VM of the web. We had always thought that Java's JVM would be the VM of the web, but it turns out that it's JavaScript. And think about that for a second. You know, how many of you have been developing Java for like 10 years or so? Anybody? Okay, so a few of you. So, you know, those of us who have been around for a while, remember, you know, thinking, oh yeah, Java's going to be everywhere. It's going to be running on every platform, whatever, right? And then, you know, iOS came out, no Java, right? The mobile landscape changed and grew very rapidly. And so if you think about it, it really is true that the platform that you can count on being on every device is essentially JavaScript inside of a browser, right? And this is why there's so many toolkits for developing mobile applications in JavaScript, not Java. So he goes on to say that JavaScript's parser does a more efficient job of providing code security than the JVM's bytecode verifier. JavaScript did a better job of keeping the write once, run anywhere promise, perhaps because it works at a higher level, avoiding low-level edge cases. And then Turing takes care of the rest. So it's sort of an interesting statement, right? We thought bytecode was going to rule the world. It turns out it's actually an interpreted language that just runs in every browser. So the fact that JavaScript runs in every browser, and the fact that computers are getting faster, we have multi-core phones now, okay? the JavaScript interpreters are getting faster, means that we have a huge explosion in the JavaScript landscape. And I'm in my day-to-day work, I do Java development. I write some JavaScript. I write more than some of my other colleagues, but my day-to-day development, I do Java. So for those of us who are in the Java ecosystem, we don't always quite notice how explosive the JavaScript ecosystem is. And because of the fact that JS is the assembly language for the platform, we've got hundreds of libraries, and they do what you expect any set of libraries to do. They fill in gaps in the language. They fill in gaps in the programming APIs. They fill gaps in the application model, and they also, come up with entirely new things as well. So we have core libraries like jQuery. How many people use jQuery? Okay, that's kind of what I figured. Prototype, MooTools, Dojo, _.js. These are all technologies that basically extend the way JavaScript works and give you a more cohesive programming model, give you lots of utilities for working with the DOM, provide all sorts of features that JavaScript doesn't come with out of the box, but you kind of wish were there anyways. Okay? And one of the things you find when you start developing large-scale JavaScript applications is you need some way to handle modules, right? JavaScript is not so good at namespaces. It's very easy to have collisions. And if you have lots of different libraries, some way to handle modules, which Java still sort of lacks, is useful. So there are systems for that as well. Require.js is one, Browserfly. And then what you find once you start writing all this JavaScript and having dependencies between different libraries and having all sorts of assets to have that you need to include together is you actually need build tools. So there's Grunt, Gulp. Grunt is the most popular one right now. And what they do is that they will take your JavaScript, all of your assets, run it through a minifier, clean it up, and package it for you so that you can then use it inside of a web application. Okay? And of course, you can run these from Maven, Ant, whatever you want. And there's even more. So on top of sort of the low-level features, we have application frameworks, right? Just as we do in Java, where we have JSF, Grails, Spring MVC, Struts still exists, Play, lots of different frameworks. We've got sort of the same thing in the JS space. The difference is these run in the browser, right? So these do a lot of the things we've done traditionally on the server, but they do it inside of the browser. So we have Ember.js, Angular.js, which seems to be the most popular, at least buzz-wise these days. Backbone.js, Mustache.js, Knockout, XJS, Kendo UI, Polymer, right? Angular and Ember do a lot of this sort of model view controller sort of stuff, or the model view presentation model pattern, those sort of big ways to structure your code, right? They provide facilities for allowing you to bind your UI elements in your HTML5 pages to JavaScript models, right? Just like we do on the server with different web frameworks. They also provide templating so that you can actually have templates that are built dynamically, right? So the same way that we have templating facilities with server-side web applications, whether it's facelets in JSF or whether it's JSP or ThymeLeaf or whatever, right? There's similar things like that in the JavaScript world. I also wanted to mention Polymer, which I find particularly interesting. How many people here have heard of HTML web components? Anybody? Ah, good. So a few of you. All right. So one of the things that's emerging is the ability to actually define new elements inside of your HTML pages, right? And these elements are basically a combination of markup and JavaScript. And once you define them, you can actually use them basically natively inside of a web page. Okay. Polymer lets you do that. Have that functionality, but have it even with older browsers that don't yet support this feature. Okay, and that does sort of overlap with a lot of the templating features that libraries like Angular have. So, of course, this is just really the tip of the iceberg. Then there's testing frameworks, Mocha, QUnit, Jasmine. And then, of course, there's component suites. So some of the frameworks and templating libraries include components, but then there are some that are really more purely components. And when I say components, I'm talking about data grids and menus and sliders and all sorts of cute little widgets that you can use in your pages, right? Because still, HTML5 doesn't have every single widget we want. So sometimes we still need libraries to have these things. And also, they also have theming. So jQuery UI is a pretty popular one. How many people here use jQuery UI? Okay, so a few of you. XJS, anybody? All right. YUI? Yeah, not so popular anymore. Bootstrap, a lot of people love Bootstrap, right? Bootstrap does a lot of stuff with fluid design, but it also does components as well. And there's a lot of overlap between these libraries. Widget is another one. Kendo UI is another one. And what's interesting about these last three ones here, it's kind of a small pointer on the big monitor here, but about Kendo UI, Ignite UI, and Prime UI. Kendo UI is from Telerik, which has been putting out ASP.NET components forever. Okay. Ignite UI is from Infragistics, which has been doing the same thing. Prime UI is from Prime Faces, which has been putting out JSF components forever. So what you're finding is that companies that have been building widgets that are integrated with a server-side counterpart are now developing widgets which can talk to different server-side counterparts, right? So these libraries don't really care what your backend is. They just want to they just make it easy for you to work with JSON, essentially. Okay. So given this, immense proliferation of different tools, and this is really just, again, the tip of the iceberg, and the fact that JavaScript is the assembly language of the web, well, it sort of follows that we really should, we should all just write JavaScript, right? So maybe we should just forget about all that Java code. We should all start using Node.js, just write everything in JavaScript and make our lives easier, right? So how many people are thinking this is a good approach for your projects? Okay, well, you're at a Java conference, so that probably would explain why. The reality is, though, we have this disconnect, right? Because we are Java developers, we like to write our strongly typed Java code. We have tons of libraries. I could have made a similar slide about the Java ecosystem and all the different libraries and tools we have, right? One of the things that we can look at is, well, maybe we can target the browser architecture without writing JavaScript, right? There are different reasons you might want to do this, but the idea of translating from one language to another, because we're assuming if we're not writing JavaScript, we're writing some other language, the idea of doing that is something called a transpiler, okay? So, transpiler, again, we have our friends at Wikipedia to demystify the world, right? Wikipedia says a source-to-source compiler, or transcompiler, or transpiler, is a type of compiler that takes the source code of a programming language as its input and outputs the source into another programming language. A source-to-source compiler translates between programming languages that operate at approximately the same level of abstraction, while a traditional compiler translates from a higher-level programming language to a lower-level programming language. For example, a source-to-source compiler may perform a translation of a program from Pascal to C. Okay? So, by using a transpiler, we could conceivably write our JavaScript code in a completely different language and still be able to integrate with the JavaScript ecosystem as much as we need to. So these are some benefits of a transpiler. So the number one benefit of using a transpiler would be to use a better language, right? And better is completely relative, right? Many people would say JavaScript is just a fine language. It doesn't need a better language, okay? Pragmatists will say that it has lots of great features, lots of functional features, and it's really powerful, can be very expressive, but has a lot of warts and issues as well. Okay, that would probably be my approach. But there are other factors at play as well, right? Maybe your team just doesn't know JavaScript. Maybe you have developers that don't know JavaScript, but also you're not really sure they can manage reams and reams of JavaScript. Maybe they can't really manage a very large application, okay? Maybe you have other forces that just make JavaScript not really the best choice for the type of development you're doing, okay? So one of the benefits of this approach is that you can write your code in some language other than JavaScript, take advantage of different language features, okay? And then if you need to, you can leverage popular JS tools, right? So all these different frameworks that are in the JavaScript world, you can leverage, but you can leverage them with a different language. And of course, that depends, right? It depends on exactly what tool chain you're using. Some of the different frameworks will actually allow you to compile or transpile your code from one language to JavaScript, but then they have a very specific set of tools that you need to use. So GWT is probably a good example of that. How many people have used GWT? Just curious. Okay. So GWT gives you the ability to compile Java to JavaScript, but you kind of are stuck in the GWT landscape. You're not really going to be using all these other JavaScript libraries that I mentioned. Another benefit, and this is a less common benefit, this really specifically depends on what tools you're using, is you might be able to use the same language on the back end. So the same way that, if you're using Node.js, you may be able to use JavaScript on the front and the back end. If you choose a language that has a powerful server presence, maybe a language that runs on the JVM, then you may be able to use the same language on the front end and the back end. And that really is sort of the holy grail, I think, for a lot of us, is not to have so much of a disconnect between what we're doing on the server and what we're doing on the client. So it turns out that there are lots of transpilers, okay? When you take a look, you can easily be amazed by the number. And again, this really does point to the fact that JavaScript is the assembly language of the web. So one of them is TypeScript. How many people have heard of TypeScript? All right, so a few of you. TypeScript is a language by Microsoft, which is a superset of JavaScript. We'll talk more about it later. There's GWT, which we've talked about a minute ago. It's the Google Web Toolkit. It includes a compiler from Java to JavaScript, but it also has tons of other facilities. So they call it a toolkit because it has lots of different, tools to help you build applications. You can even, facilities for doing REST, all sorts of UI stuff, abilities to build components, all sorts of stuff. So it's really more of a framework toolkit than just a transpiler, okay? The transpiler is just part of the stack. I mentioned something else here. Has anyone heard of ERI before? I'm not sure if I'm pronouncing it properly. So one person. So I don't have a slide on it, unfortunately, but ERI is a fascinating technology. It's from JBoss. And essentially what it does is it lets you use the standard Java EE APIs inside of the web browser running on top of GWT. So you could actually use JPA to access local storage in the web browser. You can use CDI to do dependency injection in the web browser, and all sorts of other sort of Java EE-ish features. And of course, the JPA API is going to be a subset to some degree. You're not going to be able to do everything because it's a different data store, right? But it's actually a really interesting project. So if you're interested in that sort of suite, you might want to take a look at it. But again, it's not really a transpiler. That's really a set of APIs and technologies on top of GWT. And GWT consists of many different technologies, only one of which is actually a compiler or transpiler. Another one is CoffeeScript. Anyone worked with CoffeeScript before? All right, so a few of you. So CoffeeScript is essentially a new language which makes writing JavaScript easier and cleaner and provides some facilities that make it, that are just a little bit nicer to work with. And we'll talk about that in more detail. Another one is Dart. Does anyone work with Dart? Okay, good. So there's a few of you. Anyone use it in production? I'm very curious about this. Yep, that's what I've heard too. So Dart is a Google language which which actually transpiles to JavaScript as well. We'll talk more about that. Another one is CoffeeScript, which works with Clojure, transpiles to JavaScript. Scala.js does the same thing. Anyone work with either CoffeeScript or Scala.js? Which one? CoffeeScript? Scala.js? All right, cool. So those work with those languages. Talked about Dart. Another one is Ceylon. Ceylon is a new language from JBoss. It's spearheaded by Gavin King, who's the developer of or creator of Hibernate, and also Seam, which went on to basically create CDI, which is part of the Java EE spec and does dependency injection. And Ceylon is an interesting language, and it's like a lot of the other newer languages these days in the sense that it's similar to Java, but tries to handle things a little bit differently, more concisely. Okay, and it's also very type safe. It has a fairly unique type system. And it also can compile either to the JVM or to JavaScript. So you have the option in the case of Ceylon to actually have a server-side component as well. Okay, so you could write all your code in Ceylon on the server, write it all on the client. Has anyone used Ceylon before? Or I think they say it's really Ceylon, but whatever. So it's fairly new. I think they really just came out with 1.0, I think maybe last year or something. So, I think there's mixed feelings about the language in general, but I think the fact that it's spearheaded by JBoss means that it might have a chance of catching on. Another one which I ran across fairly recently is HTML APIs via JavaScript. And if you poke around, you'll find other names like DukeScript or Knockout for Java. And it's not really a transpiler either, but I'll talk about that in more detail because it's sort of intriguing. And there are many, many more. Okay, this is really just the tip of the iceberg. And I've mentioned some specific projects, right? But let's say you have a favorite language other than Java, right? Chances are there is a transpiler for you. So, whether you like C#, C++, Groovy, Python, Perl, Haskell, Erlang, Basic, whatever you want, there is a transpiler for you. Okay? And to me, if there isn't any better evidence of the fact that JavaScript is the assembly language of the web, I think this is probably it, right? Because there aren't too many platforms that support this many languages, okay? And I'm not saying that every single project that is a transpiler for any of these languages is definitely a production level project or anything like that. However, for most of these languages, there are several different transpilers, not just one, okay? So, for Ruby, I think there's like 5 or 6, okay? So that really says a lot. For one particular language, there's 5 or 6 different transpilers. So there's a lot of stuff out there. There's also a sort of different class, and that would be Java bytecode to JavaScript. So before, we've been talking about transpilers that do essentially transpiling one language to another, okay? Java bytecode interpreters, basically what they do is they take Java bytecode, they don't care what language it's in, right? And then they spit out JavaScript from that, okay? And so basically you have a JVM interpreter essentially, okay? And there's actually a few of these. There's TVM, Back to Browser, Doppio, and Bika JVM. And I think all of these are fairly new, right? Doppio seems to be the most mature one, and Doppio is actually written in JavaScript, which is fascinating, right? So it's written in a language, transcompiled into another language. so that it can interpret bytecode from another language, right? Interesting. TVM seems to also be, have some maturity. Back to browser is actually written by someone at Oracle, but I think it has more work to do. And bytecode JVM seems probably the least mature of the four. Okay. But it's kind of interesting because we see that not only can we transpile from one language to JavaScript, we can also interpret bytecode as well. Another project which I haven't mentioned here is asm.js. Anyone heard of that one? Okay, so a few of you. So asm.js essentially gives you a very, very specific subset of JavaScript that you can use that you can then target from another language. So for instance, I think there's like a C++ compiler that compiles to asm.js. So sort of a specific dialect of JavaScript that you can target if you're writing a tool to transpile from some language to JavaScript. That's a Mozilla project. And one of the nice things about all of these projects, actually there's one, I kind of missed, oh yeah, I wanted to point this out. This URL here, this is an extremely thorough listing of every single JavaScript language compiler. If you look at that site, you'll see that what I listed is actually a subset of what's available, a pretty small subset, okay? So that list is really very, very handy if you're trying to get a view of the landscape. So as far as I can tell, and I of course have not looked at every single project in detail, but as far as I can tell, all these projects are open source, which is kind of nice, right? So, we're at a time where we've got dozens and dozens of tools that will transpile to a platform, the browser platform, right? And they're all open source, even the ones by big companies, which is really nice. All right, Kito, so you've rambled for a while. Can you show us some code or something? So here is an example of CoffeeScript. So for those of you who haven't worked with it, so CoffeeScript, essentially, I think CoffeeScript is very good if you know you're writing JavaScript and you're not really trying to make a huge leap from it, but you just want something a little bit cleaner and easier to work with some features that you think are missing. Okay. So as you can see, this is one of those languages that uses a lot of white space. There's no semicolons and curly braces and parentheses in there, or curly braces for that matter. It uses indentation. So you can see some examples: assignment, conditions, functions, arrays. It has objects. It has an actual, a more sort of classic representation of objects and inheritance. It has splats, which are essentially sort of like var args. Things like existence, so the if operator is kind of handy. And comprehension, so basically some facilities for iterating through collections in a much more concise manner than a for loop. Okay. So as I mentioned, it has classes, inheritance, and the super construct. So it goes beyond the prototypical inheritance that's in JavaScript. Has lexical scoping and variable safety. So one of the issues with JavaScript is sort of scoping, and I think that's probably one of its biggest problems, is that you have a web page that has this whole central scope, and then if you're not careful, you can declare variables which may or may not be in the right scope. Okay. If you use the var keyword, then it's scoped to the block you're in. Often people create a lot of anonymous functions to provide a block with a namespace that they can work in without polluting the global namespace. There's all sorts of little tricks you need to learn. Okay. So CoffeeScript handles this basically automatically by saying, okay, well, if you declare something inside of a block, it's local to that block, and a few other tricks. So that sort of helps out with that level of development. Pretty much all of these different transpilers provide some way to interact or to execute direct JavaScript if you need to. So for some reason, you just need to call some JavaScript and not worry about CoffeeScript. You can do that with CoffeeScript. It also has string interpolation, which lets you have a string and then put like curly braces and then a variable name in it, like Ruby does, so that you can, basically very easily construct strings without doing a lot of string concatenation, like you do in JavaScript and Java. Block strings, block comments. Block strings basically let you have a long string with several lines, which is handy. And the golden rule of CoffeeScript is really that it's just JavaScript, okay? So if you go to their website, it's actually very well done. It shows lots of examples where you can see side-by-side CoffeeScript and JavaScript, and it's really much less verbose, okay? So it's actually very nice to work with. Now, in terms of the idea of running with the same code on the client and the server, well, it turns out that any language that does this sort of transpiling, you can also run on Node.js on the server if you want to, right? So it is theoretically possible with just about any of these to have the same language on both sides. Now, that doesn't help you if you already have a Java EE app or Spring app, but it is nice to know. So another one of these languages is TypeScript. This is an example of TypeScript. So you see this looks a little bit more formal, or at least a little more familiar, I should say. So we've got a class with a student. We have a constructor. We have an interface. We have an actual, essentially a JavaScript function. But you'll notice this important thing here. Whoops. So you notice this thing here, this type, right? Hey, so as you may have guessed by the name, the TypeScript actually has optional typing, okay? Which is something which JavaScript lacks, currently at least. So with TypeScript, you can write code which looks more like a traditional object-oriented language, but actually allows you to have optional typing. So you can start out very simple by not having any typing, and then whenever you want to, you can start adding some types to it as well. So TypeScript, unlike CoffeeScript, which is actually an entirely different language, TypeScript is a superset of JavaScript. So you can actually throw JavaScript in the middle there and it'll work. So you don't need any sort of funky interoperability, right? So TypeScript, from my perspective, is pretty much as if Microsoft sat down and said, okay, what would the perfect JavaScript look like if it still had to be backwards compatible? Okay. So they basically made it optionally typed, because if it was strongly typed, it wouldn't be backwards compatible, right? They said, all right, well, if you want to use any of those dozens of libraries and frameworks out there, well, how are you going to do that and still take advantage of the features that we provided, the type safety we provided in TypeScript? Well, you can create declaration files. And these files basically allow you to apply types to existing libraries. So basically you say, all right, well, I want to use jQuery. Here are all the different functions and calls that jQuery has exposed. Let me provide some types for them, okay? So you provide that file, which they actually do have for you already for jQuery. And it basically applies typing inside of TypeScript for that library, okay? So that, again, goes with the backwards compatibility mantra. And, of course, there's type inference. So one of the things that I think is important to remember is that having types doesn't mean that you always have to declare the type, okay? That's how Java is, right? But it's possible to have type inference, and many languages like Scala have it as well, okay? So that is the idea that if the compiler can figure out what the type is, you don't have to declare it, okay? So that's something TypeScript has as well. Also has support for modules, okay? So I said earlier that there's different module systems for JavaScript, and TypeScript supports them, but it supports them with the standard syntax. Has support for generics, mix-ins, and one of the things which is different about it than pretty much anything else I've seen is that it actually uses the ECMA 6 draft when possible. So For example, the syntax for defining classes is very similar to what's being proposed in ECMA 6. Okay, so that's one of the things that's nice about it. And TypeScript is actually from Microsoft. It was released in 2012. Okay, so it has really tight integration with Visual Studio, but also there is a plugin for Eclipse and Emacs and other platforms, and it's fully open source like everything else here, so there's really nothing to keep you from using it in a Java project as well. So another one which is out there from Google is Dart. And Dart looks like this. So you can see that we've got an import. So there's the ability to have libraries. We can have a main method. You can have chaining of calls. You can have optional variables, excuse me, parameters. So you basically got a default value if it hasn't been expressed or set in by the client. It's object-oriented, so there is a class syntax and the ability to have subclasses and things like that. It has string interpolation. So you see here we're displaying this value here. It has shorthand for functions. And I think this sort of syntax is becoming very common for defining functions if you think of lambdas and a lot of other languages and CoffeeScript. You can define constructors. You can throw exceptions. And you can see basically you can return values. So it looks very similar to most languages we've worked with, right? So Dart, like TypeScript, is optionally typed. Okay, so if you want to, you don't have to define the type, but you can actually define it if you'd prefer. Has functions, and I'm mentioning things which I didn't show on the previous slide. So has functions, interfaces, mix-ins, and I didn't really mention this before, but a mix-in is pretty much what it sounds like. It's the ability to take two classes and sort of provide a unified interface that uses both, okay? And so a mix-in is pretty similar to a trait in Scala. Has support for libraries, generics, and one of the things which makes it more similar to something like Java is it also has support for metadata, which is essentially annotations. Okay, so that's something which is a little bit different about it. And also, since Google is the company behind Angular, it has Angular integration, which is nice. So there's actually a port of Angular to Dart. I think there was a session earlier on Monday about it. Did anyone attend that? Just out of curiosity. Was it good? I missed it, unfortunately. All right. So there's that. There's also integration with Polymer, which is that library I mentioned earlier, which lets you use the web components draft or the web components feature. And what's a little bit different about Dart, though, is that it actually transpiles to JavaScript or to the Dart VM. Okay. So they have their own VM. It's not the Java VM or anything like that. It's the Dart VM. And the Dart VM can run in headless mode. It can run standalone on the server, right? Or just on your desktop, whatever. But it also can run inside of the Dartium browser, which is essentially a special build of Chromium, which is the sort of raw bits of Chrome. So right now, it's pretty much just for testing. So it's nice is that you can write your Dart application and test it inside of Chromium, or Dartium, excuse me, without actually having to go back and compile it to JavaScript and deploy it that way. So sort of an interesting feature there. And as I said before, this is maintained by Google. So the last one I'm going to talk about is the HTML APIs via Java. And this is something I actually just came across very recently. And it intrigued me, but it's one of those projects where you can tell that it just hasn't quite reached some level of polish yet. So I'll show you a quick demo, and then I'll talk about it in more detail. Okay. All right. So this is the it's actually HTML API via Java, I think is the current name it's going under. And you see on the left here, I have an ordinary HTML5 page. Okay. But it is a little bit different because down here it's got some extra stuff in here using this data bind attribute, and this is part of knockout.js. Okay. So this is saying for this particular element, so button, data bind, enable, not on, click, and on click, you call root.turnOn, okay? And this is the one of the joys of JavaScript is overloading this $, right? This is for knockout. So this is basically saying when they click on the button, call this this method on the model. Okay. This is the same thing for turning it off. And then down here, all this is doing is saying, okay, for the image, we want to data bind an attribute with these values. Okay. And you see a couple of these values are dynamic, right? Root.image is dynamic, and so is root.on. Okay. And again, this is going to talk to the model. Now, traditionally, in Knockout, that model would be in JavaScript. But here, it's actually in Java. So this is what code written for HTML, horrible name, HTML APIs via Java is like. So it's very annotation heavy. So it's declared as a model. Class name is data. Okay. We've got property annotations, which are a bit cumbersome, I think. But these are essentially defining properties which are going to be available on this data class, okay, and also going to be available inside of this this web page, essentially, to knockout.js. And then we've actually got a normal Java class. So we have the class Duke to browser. It has some static initializer stuff here. So it's creating a new data. And data, because we have sort of annotated it, or basically created a class name called data and provided annotations for it, there's an annotation preprocessor, which will actually create that class. So it has a property called button text, okay? And what's happening here is we're calling button text, we're setting the properties on the model, and then we're applying the bindings. And then these are the actual methods, which are exposed as JavaScript functions. Okay. So there's switch Duke, which I don't think is actually. Yeah, there it is. Right. It's root.switchDuke right here. Okay. So when you click on this button, which is actually I'll show you it in a minute. You'll be able to switch the Duke, and actually I'll just hit run here. Yeah, let's refresh this. It's not as fast as I would like. Okay. All right, there we go. So this is that button. So down here, there's button data bind. Switch Duke, so that's this, and that's going to call this method down here called switch Duke. And all this method does is it swaps the image out. So it basically changes from one image to another, and then it changes the text to the button. So next time the button is clicked, it will swap the image in a different way. Okay. These functions are exposed with this annotation. So we've got turn on data model, turn off data model. So this is just setting that property on and off, or on to true or false. Okay. And I had to show this example when I realized that it already had a Krakow dude animation thing going here. This is supposed to be rotating. I'm not sure. Oh yeah, there we go. There we go. So you've got Krakow Duke there. So I just thought that made sense to show that one here. Basically all this demo does is you can stop it and then switch to the normal Duke and then start that one and does the rotating there. And in this particular example, it's actually really easy to make changes. So just go 33rd degree Duke. Run it again. There we go. So 33rd degree Duke. I made a little change there. So this is just a simple example, and then this is one of those projects. It's version 0.82 or something, but they just made a major announcement for it. So I'm guessing they're probably be talking about it a lot at Java 1 and trying to create some buzz or something. I'm not totally crazy about the syntax, but the idea is pretty interesting. So that's what it looks like. Let's talk about it in a little more detail. So as you can see, it's heavily annotation driven. It kind of requires a preprocessor. And also, there's, of course, NetBeans tooling to run all this annotation processing in the background, but it kind of requires some tooling to really make it work like this. It has several libraries for common browser functionality. So you can do things like JSON, WebSockets, sound, geolocation, etc., using the APIs it provides. And as you can see, it can integrate with knockout.js. I don't think you have to integrate with knockout.js. I just think that's the way that you can integrate with HTML5. Okay. I think if you wanted to write some arbitrary Java code and have it turned into JavaScript, you don't have to use knockout.js. And it's a NetBeans sub-project. Now, basically what's happening is there's a whole bunch of APIs and framework code around this particular way of writing Java code, so that it can integrate with Knockout and provide some other high-level abstractions. But at the end of the day, it's running on TVM or back to browser. Okay, so at the end of the day, it's actually being compiled to bytecode and then using one of those Java bytecode to JavaScript compilers. Okay, so that's HTML APIs via Java. So the bottom line is that JavaScript is the assembly language for modern web applications. I think that's pretty much clear. Whether or not you agree with the exact analogy of assembly language or VM or whatever the case may be, it's pretty clear that essentially for modern web application, it is the target platform. So either you use JavaScript, just write JavaScript, and the benefit of that is that you don't have to worry about any extra tool chains, right? You also will be able to take advantage of new language features as they become available. So there is work on ECMAScript 6, which will be out at some point. I don't really know the timeline, but that's something to watch. So it may be that some issues that we might have with JavaScript may go away. So for example, the ability to have a more classic inheritance structure is actually something that will probably happen, okay? But at the end of the day, you need to choose your tools wisely, right? So there's lots of choices for transpilers. I encourage you that if it's something you're interested in, to sort of take a look at the landscape and see what might work for you and the teams you're on. What's nice is that at the end of the day, we have a lot of choices, right? Choices can also be paralyzing. But it's nice to know there are so many options. So if you're in a shop and you want to look at having tools of the same language on a client and server, that gives you a certain set of options. If really you just want a way to write a little bit cleaner JavaScript, that gives you other options like CoffeeScript. If you have a particular project where you know you're writing lots and lots of JavaScript, maybe thousands and tens of thousands of lines, you may want to look at some of the transpilers that have a language that gives you better constructs for very large applications. Okay, so there's lots of stuff out there. Choose your tools wisely, and good luck. Thank you.